we'll do the same program for decimal types. So whenever we are using decimal types, right, similar to int and long, okay, so we have other two data types, which is float and another one is double. So float will store decimal numbers and double will store the decimal numbers, but it can store with a higher precision, double the precision of float. Yeah. So whenever you're working with huge scientific programs, there you probably use double with large precision, like too many decimal digits. But most of our programs for interview purpose, we probably use float. Yeah. So I will have this demo using float. Same program, we'll try to convert it to a floating point type. Yeah. So for this purpose, okay, so I will use this whole structure and I will use a different color probably just to indicate, and I will strike off this piece, yeah, and try to have a floating point demo. Okay, so very similar to this, we will start with float. Float is a keyword, int is a keyword, remember. So float a and then float b. I'm declaring two variables, float a and float b. Similarly, float result. So I'm trying to use the same variable name because this is a different program. Yeah. Now a equal to, so I have to store a decimal number. Yeah. So let's say 2.3, and I have to use explicitly f as a letter indicating it is a floating point number, because by default compiler assumes such numbers as double numbers, and whenever you are trying to use such 2.3, it will think it is double and you are assigning it to float, so it will start complaining it. So you will explicitly say I wanted to use 2.3 as floating point number. Similarly, b equal to, let's say, 4.0 float. Yeah. Now result equal to a plus b as usual. Yeah, and then display the result using system.out.println result. So instead of int, we have just used a float here. Yeah, so this is one way. And quickly, just to show the previous example, right, I can also write, sorry, float a comma b comma result. Yeah, so this is a comma here. Yeah, between data type and variable there should be a space. Yeah, float a and a equal to 2.3 f. Yeah, b equal to 4.9 f, and result equal to a plus b, and then display the results, same statement. So this is also another way of doing it. Yeah, and the third way also we have seen, very similar to the previous example. Yeah, so float, 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 yeah, a equal to 2.3 f. So I'm declaring first variable. Similarly, float b equal to 4.5 f, for example. Then in the next line, float result equal to a plus b, and this is the printing. So whatever the way you want, yeah, you can actually use it. Yeah. Similarly, you can try out with the double. Yeah, and also make sure you Google or look at the Java documentation to see the range of numbers. For example, if I'm using byte, what range of numbers I can see, from what negative value to what positive value I can actually store the numbers. Yeah. So for example, if you're using negative numbers also, right? So you can always use it this way. For example, float a equal to minus 2.3 f. So something like this. Yeah. So we will start using these things in our programs, and you will automatically start getting all the things. So basically in these demos, what I really wanted to say is, if you're using numbers, yeah, most of your programs either you'll be using integers or floats. Yeah. But one thing we need to remember always, for example, if I'm adding 2 plus 4.5, what will be the result that you expect? Yeah, so this is an integer number and this is a floating point number. So obviously the result will be a float, right? So there is a possibility that in your program you are using integer a equal to 2, yeah, and similarly the other number float b equal to 4.5 f, yeah, then when you are declaring result, right, so it should be obviously float result equal to a plus b. So you have to make sure whatever the operation that you are performing, yeah, so what could be the result it can yield. So normally what happens is if I'm performing an operation between int and int, the result will be int, yeah. If I'm performing between float and float, the result will be float, yeah. If I'm performing between integer and float, the result will be float. So always on the higher side, yeah. Similarly, if I'm performing integer and long some operation, yeah, what could be the output? It is going to be long. So we need to remember these things, yeah. And based on that, we have to ensure we use appropriate data types declared, or variables declared with the proper data types, yeah. This is one thing. But sometimes what happens, right? Basically, like I have a variable and I have b variable. This is integer type, yeah, and this is floating point type, and I'm performing a plus b, yeah. But I want it to be an integer operation, yeah, for uh, some reason, let's imagine, yeah. So you may ask like why you have declared b as a float, then you could have just used integer, yeah, that's fine. Just imagine that, okay, I wanted one variable a and another variable b. A is of integer, b is of floating point type, and I wanted the operation result to be integer type, yeah. So in that case what happens, so for example this is integer a equal to, let's say, 2. This is my variable, yeah. Second variable is float b equal to 4.3 f, yeah. Now suppose if you have integer result, okay, equal to a plus b, if you write like this, yeah, then immediately what happens, compiler complains saying you have performed an operation which is resulting float, because b is a float here. A plus b will result a floating point result, and that floating point result you are trying to assign it to integer, which is not possible. You can't do it, because how can you store, for example here it is 6.3 into a place integer where you can't store decimal numbers, yeah. But if you still need it, you wanted it, okay, then you have to explicitly inform compiler that yes, I wanted to use integer result only, I wanted integer operation only on a, but I wanted this b to be converted into integer. So in the bracket we are saying integer. So this is called typecasting. So I will explain this separately in a video where we will have these implicit and explicit type conversions. Yeah, but this is also possible. So what I meant here in this video is we just need to be very careful what type of operation we are performing. Sometimes, very rarely, you may encounter a situation you have to explicitly convert the types. Most of the time, for example, if I have integer a equal to 5, for example, and another one is float b equal to 4.3, okay, and if I'm performing a plus b, actually the result is actually upgraded to float itself. Yeah, so system takes a as 5.0, even though it is integer, it upgrades it to float automatically, and b is anyway float and performs operation as a floating point operation, as a decimal operation, and hence results will be float, yeah, and hence you are expected to store this in a floating point variable, yeah. But sometimes if you need to implicitly, sorry, you need to explicitly tell, no, I don't want the standard way, I want slightly in a different way, then we use something called typecasting, yeah. So we'll see that typecasting in some future videos, but for now, so we have seen how to use integer and float. Similarly, try out this with the double and long.